All right, for the second part of section 1 of unit 8, again, the first part should have gotten you enough information that on the homework you should be able to do numbers 1, 2, 3, and 4. Again, it's gotten you the little hint there of using the Pythagorean theorem. In case you forget, you've got to find that missing side. Once you've done that, coming down here to the next part of the notes, we're presented with something a little bit different. We're given an angle and maybe one of the sides and asked to find another side. In order to make this work, you've got to decide which of our three trig functions we need to use. So we've got sine, oh, my eye apparently disappeared there. Sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. So each time you do this, you're looking here at letter A and you need to decide, okay, which of those three is going to be able to line up with the information they gave me. So they gave me an angle right here, 35 degrees. They also gave me a side. Specifically, this is the adjacent side, and that's important. They did not give us the opposite side. They did give us the hypotenuse. Once you've decided on that, you know which of our three functions we're going to use. Adjacent and hypotenuse is cosine. So I'm going to set this up. Cosine of 35, and again, we usually abbreviate cosine as 30, or cosine as COS. So cosine of 35 degrees is equal to the adjacent side, x, the one I don't know, divided by the hypotenuse of 16. So there's our equation. There's two ways of answering this. You can give an exact answer, or you can give an approximate answer using a calculator. I personally prefer the exact answer, and the test is going to ask you for the exact answer. The exact answer means taking what we just did, solving for x, so that means multiplying both sides by 16, and I get 16 times the cosine of 35. That is our exact answer, and that's actually the one I prefer. The instructions here on the notes, though, do say to go ahead and get an approximation. To do that, you need a calculator. You all probably have phones, or there are scientific calculators that you could use. The key here is to make sure that your phone or calculator is in degrees. We're dealing with degrees right now. Every single scientific calculator and phone can get you answers in two different formats, degrees and radians. We'll be dealing with radians in a few sections, but not yet. Right now, we want degrees, so make sure that your calculator phone shows a little D symbol somewhere as opposed to an R, so that when you put that in, and again, everybody, you can go ahead and check and give this a shot. You can grab your phone if you've got one, or a scientific calculator, plug this in here and see what you get. You would do on an iPhone. If you have an iPhone, you're going to do the 35 and then hit the cosine symbol. If you do that, you should get 0.819 or so, and then times 16, and you should get 13.106. And the instructions here say to give this to the nearest thousandth. So that's what I'm going to put. X is equal to 13.106. That's an approximate rounded answer. So really, these shouldn't be equal signs. These should be little wavy, approximately signs. I actually don't like that answer very much. I would prefer you to put 16 times the cosine of 35, and you need to be able to get that. There's going to be multiple choice questions on the test that ask you which of these would be the answer. It's going to be in that format. If you want to get a approximate answer to kind of get a better handle about what that actually means, go for it, but make sure you're practicing getting the exact example or the exact answer as well. So on to the next one. We're given different information for this one. I still have an angle. I still have a side, but this time the side is across from my angle, which means this is the opposite. And this one up here is still the hypotenuse. So when I set this up, opposite and hypotenuse is sine. So I'm going to do sine of 70 is equal to x divided by 14. I can multiply both sides by 14 here to get that x by itself. So my exact answer is 14 times the sine of 70 degrees is equal to x. Again, that's the one I prefer. If you give me that one, more than likely, I'm going to give you full credit for it. But if it does ask you to round, as this one does, go ahead and try it, put it in a calculator, and you should get here 70. Take the sign. If you're using if you're using an iPhone, you have to do it in that order: 70 sign, and then times 14. Some scientific calculators will make you do it that way as well. Others, where you can put it all in one step, you can do 14 times sine of 70. Either way, you should be getting 13.1556, so round to 156. Again, it's a good idea to practice that right now. Make sure you understand how your calculator is working. If not, maybe check with somebody else nearby that has the same calculator or phone, see if they can help you out. Next, same idea, but this one's got a twist to it that makes it a little bit harder. When I set this up, I have the opposite side and the hypotenuse. Opposite, hypotenuse. I'm setting that up then with sine. So sine of 20 is equal to the opposite side 10 over the hypotenuse h. Here, I need to get that h out of the bottom. In order to do that, I'm still going to multiply both sides by h, but we often have students that want to just divide both sides by 10. The problem is that gets you, instead of h, it gets you 1 over h, which is actually not helpful right now. So we're going to multiply both sides by h. That cancels out. We have h times the sine of 20 is equal to 10. Now I can divide both sides by the sine of 20, getting h by itself. Divide both sides by sine of 20. So h is 10 divided by the sine of 20. And that's what I could put in the calculator, get an approximate answer. So if I do that again, if your calculator does it step by step, you'd put in the 20 first, then hit sine, get an answer, write that down, and then do 10 divided by that. So I'm getting about 29 for that one, 29.238. So h is about 29.238. It's always a good idea to make sure your answer is reasonable. This is the hypotenuse we're talking about. It should be the longest side. It's bigger than 10, but not astronomically so. And again, that 10's across from a small angle, 20. So it makes sense that the other sides would be a good amount larger than that. And one more here. We've got an opposite side and an adjacent side. That means tangent. So tangent of 15 is equal to opposite over adjacent, 9 over x. Again, we're going to have to multiply both sides by x to get it out of the denominator. Then I have x times the tangent of 15 is equal to 9. Then I can divide both sides by the tangent of 15. That way, again, the tangent of 15's cancel out on this side, just become 1. And I'm left with x is equal to 9 over, make that a 9. That looks kind of like an A. Let's try that again. 9 over the tangent of 15. If you put that in a calculator, you should get approximately 33.588. Again, if you're not getting that particular answer, check with somebody nearby. Double check, make sure you're not in radians instead of degrees. You must be in degrees. And again, every calculator that I've seen can do both. With that information, you should be able to handle 5, 6, 7, and 8. Oh no, sorry, just 5 and 6. We need to talk about how to find the angles now for 7 and 8. So you could pause the video here for a moment, try and maybe number 5. Just 2 minutes, double check with everybody in the class, everybody at your group. And once you've done that, let's come back over here and talk about how we'd solve for the angle. So E is actually still solving for a side. The one trick here is that you have 7 root 5, which complicates things just a little bit, but the way you set this up, I'm still dealing with the adjacent side and the hypotenuse. So I'm still setting this up as cosine for the adjacent, cosine of 63 is equal to 7 root 5 over x. So I'm multiplying both sides by x, then dividing by the cosine of 63. So I'm going to skip those steps and go straight to x is equal to 7 root 5 divided by the cosine of 63. Again, some of you are going to get fast enough. You're not going to have to show those middle steps. If you're not sure what happened right there, check with somebody next to you. Now, when I put this in a calculator, I'm going to have to do 7 times the square root of 5 and get an answer. And then I'm going to divide that answer by the cosine of 63, which should get us about 34.775, or approximately 34.478. Once we get to F, though, we now suddenly find that we're looking for the angle itself. To find the angle itself, we're going to set everything up the same way. So here I've still got the opposite and hypotenuse. So I'm setting this up as the opposite and hypotenuse is going to be sine of x is equal to 12 over 17. But now I'm going to use a completely different function, the inverse function of sine, to be able to get my answer. So to do that, I'm going to take the inverse sine of both sides. Technically what I'm doing, although you almost never write this all the way out, I'm taking the inverse sine to the -1 power of both sides. Same thing over here. This would be sine to the -1 of this side. The sine to the -1 and sine here are going to cancel out, and I'm going to be left with just x is equal to the inverse sine of 12 over 17. Every single calculator that can do sine can do inverse sine. Oftentimes it's when you hit a second button or a shift button or something else on your calculator. So take a look at your calculator or your phone, see if you find a second or a shift button, look for that sine to the -1. You're going to put that in now, do 12 divided by 17, get an answer, and then take the inverse sine of that answer. So on an iPhone, you're looking at doing the second button and then hitting sine to the -1, and it'll give you that answer. If you're using a different kind of calculator, you may put sine to the -1 in and then write the fraction over 12 over 17. This is going to give us, again, this is the exact answer. This is the one that I personally like, but if you want an approximate one to kind of know exactly how big that is, we're looking at 44.9008 or 901 here. So that would be my degree for x. And again, that makes sense. That angle's a little bit off of a 45-degree angle, but pretty darn close. Next one, same exact thing. You're going to use the inverse of whatever function you've got here. So for this one, looks like I'm dealing with tangent since I have the opposite and adjacent sides. So tangent of x is going to equal opposite over adjacent, 6 over 14. You can reduce that if you want to. And if you're going to leave your answer as the exact one, you probably want to write this as 3 over 7 then. That's what it shifts to. But then when I take the inverse tangent of both sides, I get x is equal to the inverse tangent to the -1 of 3 over 7. That's my exact answer. That's the one I prefer. That's what's going to be on like multiple choice questions on the test. But if you want an approximate one, do that inverse tangent of 3 over 7. And that would get you, oops, that did not work. Try that again. 23.1985, or about 23.199 degrees. Again, if you're finding an angle, your answer is going to be in degrees or later on radians. For letter H, same exact thing, but we've got a square root again. So I'm setting this up. Looks like I have adjacent and hypotenuse here. So cosine then. Again, if you did not write down sine, cosine, and tangent, raise your hand right now. Tell someone to pause this video so you can write those down. You need sine, cosine, and tangent, and hopefully to have them memorized as quickly as possible. Once you've got that, it's pretty easy then to see, oh, I've got adjacent and hypotenuse. That's cosine 2 root 19, the adjacent side divided by the hypotenuse of 25. At this point then, I can take the inverse cosine. Theta is equal to the inverse cosine of 2 root 19 over 25. And again, the idea would be to actually find what if you want the approximate answer, find what 2 times the square root of 19 is. Get that answer, then divide it by 25, get that answer, and then put that into the inverse cosine. Now, if your calculator can handle putting all of that in at once, that's going to be best, because every time you write it down part of it and then plug it back in, you're losing some of your accuracy. But again, you're only rounding to 3 decimal places, so you're not being super accurate anyways. 69.5914 or 69.591. And again, that should take you all the way on the homework through, looking down here, number, that's 7 and 8. And then you've got, again, some of the ones that we did before, solving for a side with a square root. At this point, you should be good all the way through number 12. The last couple of things that we're going to go over today are completely solving right triangles, which really means putting together everything we've been doing and getting the exact answer for, or the approximate answer for, all the pieces of a triangle. So what's the missing side? What's the missing angles? Fill it all in. So for this one, for letter A, I need another angle up here. I have a 30, a 90. If I was here in class, I'd ask you, hey, everybody, what do the angles of a triangle add up to? Hopefully you all know. I'm looking at 180 equals 30 plus 90 plus that missing angle. We'll call it angle B up there. So if I solve for B, subtract 90, subtract 30, I'm going to get B is equal to 60. Now, this should ring some bells for you guys. You hopefully did some work with these special right triangles before last year. And the hope would be you see that 30, 60, 90, and you go, oh, I've dealt with this before. Notice the instructions here say use only right triangle trig and the sum of the angles of a triangle to solve the triangle, meaning you do not need a calculator for these. You should be able to find all the information you need because it's a 30, 60, 90 triangle. 30, 60, 90 triangles always have the same proportions. The short side is 1, the hypotenuse is 2, and the long side is the square root of 3. Now I say long side, that's just long in comparison to the other leg of the triangle. The hypotenuse is always the longest side. Square root of 3 is less than 2. So we've got 1, 2, square root of 3. You need to have that memorized as well. If you haven't seen this before, put it down on a note card. Make sure you know to start studying this. 30, 60, 90 triangles. Across from the 30 is a 1. Across from the 60 is a root 3. Across from the 90 is a 2. Now, this one's already been filled in. They say that this side isn't just the square root of 3. It's 4 root 3. That means this triangle has been blown up, expanded 4 times. So instead of it being 1, 2, square root of 3, it's the side's 4 root 3. That means divide by that root 3 and you get this side. A is 4. And then multiply that by 2, you get C, the hypotenuse is 8. So this is 4, 8, 4 root 3, which is the exact same proportions as that 1, 2 square root of 3 that we were just talking about. So you can take that 1, 2 square root of 3 and multiply it by any constant that you want. As long as all 3 get multiplied by the same thing, the triangle expands. It's still the same shape, same proportions. It's just a blown up triangle, kind of like on a projector. Now that's one of our triangles. We have one other one, which is right here. This guy is a 45, 90, and that means the other missing side, in order for them to add up to 180, is 45 degrees. 45, 45, 90 triangles always use the proportions 1, 1, square root of 2. So just like with the last one, as soon as I see that 45, 45, 90, I know it's one of my special right triangles. I know it's 1, 1, square root 2. This one has been expanded by a factor of 5. So everything got multiplied by 5 as far as the sides go. This is 5 root 2 instead of just root 2. That means if I divide by the square root of 2, this is 5 and this is 5. There is my completed special right triangle there. You must have those 2 triangles memorized. Sometimes you'll see a third one, but this is just the 30, 60, 90 triangle flipped around so that you're concentrating on the 60 degrees instead of the 30 degrees. Just having these 2 memorized is going to be enough. And that's really all you need to be able to fill out the rest of the homework. So here we've got those same 30, 60, 90 triangle, 45, 45, 90 triangle. You're filling in the missing parts. Angle A, side A, side B that are labeled here. Down here, this one wants you to use, this is on the homework again, so we've switched over. I'm going to give you a little hint on these guys. I'm going to get you started on this. So have out your homework and make sure that as you're looking at this, sine of 30, well, here's the 30 degrees, opposite over hypotenuse. That's A over 2A. That's the proportions of any 30, 60, 90 triangle for sine. But notice that the A's cancel out. And what this means is sine of 30 is always 1 over 2. No matter how big the triangle is, it's always 1 over 2. The same thing's going to happen for each of these. If I do cosine of 30, that's going to be a root 3 over 2a. And then the a's again cancel out, and I get root 3 over 2. So no matter how big the triangle is, cosine of 30 is always root 3 over 2. And then the tangent, opposite over adjacent. A over a root 3. A's cancel out, 1 over root 3. But that should ring a little alarm for you guys. Think back to section 6. We cannot have a square root in the denominator. So I need to rationalize this. Multiply top and bottom by the square root of 3. Just like we did in unit 6. Top and bottom by the square root of 3. So that I end up with root 3 over 3. You should be able then to do 16 and 17 for those using these two triangles that they've already given you. Here are the perfect or the special right triangles that you should have memorized. You're using those then to try to find these two. You're going to have to divide how these two triangles have been shrunk down from these two. So how do I go from a 2 to a 1? Whatever I did there, that's what I'm going to have to do to the other two sides. Put those in. This part, this is a little interesting. This is the same stuff we've been doing, but rephrased. I have a nice little triangle here. It's a 30, 60, 90 triangle. Except, notice that the hypotenuse is a 1. Once I've figured that out, that's actually the same triangle you were finding up here. So once you've got this one filled out, you know what these two sides are. This side is this guy right here. This side is this guy right here. Once you've got those are your coordinates here. The coordinates would be the x direction. And let's use some different colors here to make this a little bit clearer. The x coordinate is going to be this adjacent side of the triangle. Whatever you get there, that's your x coordinate. Whatever you got for your opposite side, that's your y value. That's how high up this point is. That goes here. So by solving these two triangles, you can fill in these. This right here is leading up to what's going to be called the unit circle. It's essentially all the different pieces of trig that we're learning right now condensed down into one diagram, which we'll talk about around section 4 or 5. But at this point, you've got everything you need to finish up the homework here for section 1.